Your warm up, and I'm going to give you some time, guys.
Hey, be quiet. I'm trying to focus. God, it's every day.
No. Quiet, Carlos.
Okay, you need to use the pictures. You have some to the right here and some more at the bottom to help you fill in the blank. There might be one or two that you might not be familiar with. That's okay. But I'm going to give you about 3 minutes, maybe 5 max. I don't think you need that much. To answer 1 through 8, these are parts that you should be familiar with to a three-dimensional shape. So do your best. We're going to check it, and then this is what we're going to get into. You got to know the parts in order to implement the formula. We just finished our notes. We just finished. Okay, so the two congruent parallel faces of a prism are called the bases. Okay. The other faces of the prism are called the lateral faces. I was hoping that you could see that in the figure if you weren't even too sure, but you got to identify those parts and what we're going to get into. All right, so the lateral edge, I'm ahead of myself. The lateral edge of a prism is the edge that is not one edge of the base, and the axis of a cylinder is the segment that joins the center of the two circular bases. Now, an altitude, okay, an altitude of a prism or cylinder is perpendicular. It's a perpendicular segment that joins the planes of the bases, and the height of a prism or cylinder is the length of the altitude. All right, so you need to understand that these two, altitude and height, are basically the same. They can be interchanged. Rahel, stop. All right, you're going to be looking at today lateral area, which is the sum of the area of all lateral faces. And you're also going to be looking at the total surface area, which is basically the lateral area and the two bases, the two base areas, okay? All right, so the first thing, which I'm hoping you recognize, this right here, this formula can be used for a prism or a cylinder, and this is representing the total surface area, okay, of all the faces. All right, so if you have a highlighter, use the highlighter, box or star. Okay, so what I want us to make sure, guys, the first step, and the reason why I want you to get a highlighter, not just to highlight the formula, but the first step to doing surface area or volume, which is what we're going to get into, the first step that you have to be able to denote and identify, and that's why highlighting it will help you make sure you're using the right part, is you have to identify the base. You have to find the base of the prism or the pyramid. And sometimes I'm not going to give it to you already put together. I might give you the net of the shape. So, for example, this is a prism. There are two bases. What is the base? The pentagon. So that's why you need to get a habit of highlighting a base. I know there's two for a prism and they're congruent, but you need to highlight the base because that is your starting point. And if you highlight the wrong face, the wrong shape, all your calculations will be off. Okay? So like in a cylinder, what is the base? That circle. Okay? In this pyramid, and we kind of debated about it earlier today, some said trapezoid, others said pentagon, but because they were looking at, you can't really see the other two edges in the back. So it looks like, the reason why they said that is because it looks like these two are coming at an angle. But finding the base is the first step. If you do not identify the correct base, everything else is going to be wrong. So make sure you can do that. Okay, so for pyramids and cones, there is an additional part that you have to recognize in a pyramid and cone that's different from a prism or a cylinder. All right, so first of all, when you're dealing with the pyramid, it has only one base, okay? Whenever you have a pyramid, it has only one base. That is a polygon. And the lateral faces are triangles that meet at a common vertex. So the triangles here meet at a common vertex. Now, if you notice over here, I'm hoping you see that the base is a rectangle. This is our base down here, okay? The height or the altitude has to be perpendicular from the base to the vertex. If it's a prism, it's from the base to the base, okay? And then we have a new part, which is what we call the slant height. Now, if I'm looking at a regular pyramid, then the base is a regular polygon. That means all the sides and all the angles are congruent. Now, if I'm looking at the perpendicular segment, that's the height of the pyramid. The segment that's perpendicular from the base to the vertex, that's the height. Now, this is the new one that you're going to use for a pyramid, which is called the slant height. Okay, I'm hoping it's real simple to determine between the height and the slant height of the pyramid. Do you see the difference between height and slant height in your picture here? Okay, now, also understand that this slant height rests on the lateral face, rests on the triangle. It is the height of the triangle. Like if I was to take this piece right here out and redraw it, that slant height, is the height of that triangle. It's the same as what? No.
Like what if you opened it a little bit?
Yeah. It's not the same. Yeah. Okay. He's right. If I was to open this piece out, it's not necessarily going to be the same height as the height from the vertex to the base, because it's slanted. Okay. All right. So now, when we're talking about a cone, notice that the slant height is kind of like the edge of a cone, but we only have edges with cones. But it's right here. It's the height that's slanted, and the height or the altitude is the distance from the base to the vertex of the cone, okay? Now, when we look at the surface area of a pyramid or cone, is the sum of the lateral area and the base area. Okay? And this is the formula that we're going to use for pyramid or cone. Lateral area plus the base area. All right, now we're going to look at pretty much how the surface area is broken up into pieces. And I just want you to take a moment and watch this visualization of how prism cylinders are formed and how you can see their surface area. Because especially the cylinder, I don't know if everyone's going to be able to pick it up on this little, Mason, will you get the lights for me? Yeah, that's fine. Oh, what happened to it? No. Yeah, sent me. Watch. All right, so what you have up here is an example of how the formula has been derived. Okay, so here's the thing. The key to this is really finding the base, identifying the base, and then finding the parts to the base, which is your area and your perimeter. Oh, sorry. Were you stopping for me? It's right over. Yeah. Thank you, Charles. It's that one. I got it. Thank you. Okay, so what they're trying to show you here, like normally you do perimeter, you always add up the sides, right? Okay, so it doesn't matter what type of prism you have. If I add up the sides, like this is, I know the green part is the base, and the sides, let's say it's BCDE or BCD, okay? When you add that up, that represents the perimeter, okay? So if I want to find the lateral area, that's every face besides the base, right? I'm taking the perimeter and then multiplying it by the height, because if I did the rectangle, that would be base times height, right? So the perimeter is this length times the height. That's why to find just the lateral area, which represents those rectangles, I can take the perimeter and multiply it by the height. So also, the height, whenever I give you the net, is the distance between the bases. Okay, so that, because sometimes I might give you a net, sometimes I might give you the three-dimensional shape. So the height is how far apart the bases are. And then to find your your total surface area, you take the lateral area plus the two bases, the area of the two bases. That's why it's 2b here. Okay, so we're going to use that formula relationship to find the surface area of this prism. Okay, what type of prism is in the example? Yeah, it's a triangular prism. Okay, so to find the lateral area, the formula is just pH. But the first thing we have to always do is identify, which is basically your B, right? So what shape is going to represent the base here? Yeah, the triangle. All right, so whether you do the bottom one or the top, okay, they're the same. They're congruent in a prism. Here's my base. I'm just going to shade it so we can see it, okay? All right, so my B, the base of the triangle. Therefore, to find the area, you're going to have to do base times height divided by 2 to find the area of that base, because it's a triangle. What are the base and the height of the triangle? What's the B and the H of the triangle? No, nothing? Huh? Yeah. It's a 3 times 4 divided by 2. The base and height are always perpendicular to each other. Okay? The base and height, it's a right triangle.
Oh, okay.
All right, so the area of our base is going to be 6, right? Centimeters squared. Now, the second thing you have to always find is you have to find the perimeter of the base. The distance around the base. Our base is a triangle, so I want to know what's the distance around this base? Yeah, it's the same as the one above.
How do you know the
Yeah, Pythagorean theorem will help me find.
yeah, it's a right triangle.
It's a right triangle. So think of it. Is it 3, 4? What's this have to be? Yeah. It's a 3, 4, 5 triangle. So my perimeter is 3 plus 4 plus 5. Yeah, our perimeter is 12. Okay. Several. Oh, well, the beginning steps are really 3. It's base, the B, find the P, and then after that, it's find the formula and plug it in. Okay? All right, so our formula here is pH. This basically means to find the lateral area. LA is usually what they use to abbreviate the lateral area. You're going to take whatever the perimeter is times the height. Okay? Lateral is basically taking the perimeter of the base, and the perimeter is always of base. Might need to write that. The perimeter of the base times the height. Okay, height of the prism. So we already know the perimeter of our base is 12. What is the height of the prism? Yeah, the distance between the base is 6, so that's the height.
Is that for one lateral face or is it for all?
For all of, like, the whole total lateral area. All right, so that means that the lateral area is 72 centimeters squared. Now, after we have our lateral area, I need the B to get the surface area. The B in our problem was the triangle. So that was our base times our height divided by 2, because we had a triangle. That was the 6, the area of the base. Capital B always means area of the base. Okay, so this was our 6 centimeters squared, which we did already. So basically, we got that by saying 3 times 4 divided by 2. And that was our 6 centimeters squared. All right, so surface area means you're going to take the lateral area plus the area of the 2 bases. That's why it's 2b. Okay, we already know our lateral area. That's the 72. Plus, we're going to do 2 times the area of our base. Our base is 6, which is 12. So our total surface area would be 84 centimeters squared. Yeah, centimeter square. Area is still centimeter square. Unit square. Okay?
Volume is feet, right?
It's cube, yeah. All right, now, what they want you to see is the formula that we use for lateral area, which is pH, is the same thing. It's the same formula even with the cylinder. You just got to kind of break it down. What does P represent in the cylinder? Circumference, yeah. In a cylinder, because we have a circle, okay, if I'm going the perimeter around the circle, the distance around the circle, so this P is actually going to be the circumference of the circle. All right, the circumference of a circle, typically, we use the formula 2 pi r, right? So in the formula for lateral area, we do the perimeter times the height. But since we're talking about a circle, our perimeter is 2 pi r. Yeah, circumference times the height, exactly. So basically, we're just taking the 2 pi r, which is our perimeter, which is really the circumference, times the height. That's how you get 2 pi RH. Now we're going to leave our answers in terms of pi, okay? Meaning we're not going to multiply or convert to 3.14 or use the pi button unless I ask you to. So we want exact answers, so we're going to leave it in terms of pi. So what is the circumference of this example here? Not 4.
That's just 3 pi.
Yeah, this is just 3 pi. Circumference here is just 3 pi. The diameter pi is the same thing as circumference of 2 pi r. Okay, 2r, exactly. So we have the diameter, so it's 3 pi. All right, so I can plug this in and say we have 3 pi, that's the circumference. What's the height of the cylinder? 4, so I'm just going to say 3 pi times 4, so we get 12 pi centimeter squared. Lateral area. This 12 pi would be this part in here, if I open that up. Just that rectangle part. All right, so B, capital B means what? Area of the base, right? Okay, our base in our cylinder is what shape? Circle. So the formula to find the area of a circle, pi r squared. So we are going to find the area of our circle, which is pi times the radius. The radius would have to be half the diameter, 1.5 squared. That's the formula for a circle, area of a circle. Pi r squared. And that's the base. So this was 2.25 pi centimeter squared. Okay? Now, to do our lateral area, our total surface area, the SA, normally would do what we did before. We take the lateral area plus the 2b. Okay? Well, if I want to convert this dealing with the circle, we already know the lateral area is 2 pi RH, right? Plus 2 times the area of a base is pi r squared, right? So that's how the formula kind of gets changed for a cylinder, because you're just substituting the parts. So now I'm just going to substitute what I have. I know the lateral area was 12 pi, and I know my area of the base was 2.25 pi. All right, so I'm going to double that and add it together. 4.5. Don't we get 4.5? When you double it? 4.5? Yeah, okay. So this is 16.5 pi centimeter squared. Okay? All right, so now, this is when we have to, when we're talking about pyramids and cones, now when you have only one base, this is when we have to start looking at the slant height, or identifying the slant height. You still do the base first. You're still going to identify the base first. But remember, from the inside, from the center, or from the base to the vertex, that is the height. Okay? When I'm looking at on the face, the triangle, this is the slant height. You got to know the difference. All right, the first thing is still going to be identifying the B. What represents the B in our example here? Yeah, B is a hexagon. Okay, it's a regular hexagon. Now, our formula is going to be a little different, where we're now going to do 1/2 the perimeter times L, which is our slant height. So the first thing, after I find the B is a hexagon, I need to know what the perimeter is of that hexagon. So what would the perimeter be of this hexagon? Yeah, it would be 36. 6 is our sides. There's 6 of them. And 9 is your slant height. And I probably need to move that. Let me move this over. Okay, so the perimeter is 36. This 9 right here represents the slant height. Okay. So we're going to do 1/2 times our 36, which is our perimeter, times our slant height, which is the 9. 1/2 times the 36 times 9. 18 times 9, yeah. Half of 36 is 18 times 9. 162? What is? The L? Yeah. That's the symbol for slant height, yeah. 162 inches squared. All right, now, what does the capital B represent again? Area of the base. Okay, our base we know is a hexagon. So the formula to get the area of this base is going to be 1/2 the apothem times the perimeter. Now, I believe they gave us the apothem. Yep, so we're going to do 1/2 of the 3 root 3, 3 squared root of 3, times the perimeter, which you already calculated, which is 36. This is going to be a radical answer. Half of that. Yeah, 54 square root of 3, and this is inches squared. Okay. Now, to get the total surface area, you're going to do the lateral area plus the area of the base. So we already know the lateral area is 162. The area of our base is 54 root 3. All right, so what would I need to do to show the exact answer? No. Exact answer. There it is, right there. That's the exact answer. Okay, if I put it in the calculator, what is the calculator going to do? It's going to give you decimals. It's going to give you an approximation. So if I ask for the approximate answer, so put it in the calculator and figure out what the approximate answer is. And some of y'all need to get a calculator, so go ahead and do that. You're going to need it today. All right, to the nearest 10, we should get 255 point what? 0.5 inches squared. Okay? Now, you're going to need your calculator today because we're going to start looking at some practice problems that I am going to check off today. We will try to think if I want to do the cone. Yeah, we'll do the cone tomorrow. So, yeah, we'll do that tomorrow. So, go to your homework packet. Eighth period. Okay, I already told you yesterday, page 3. Page 3 all. Okay. Page 6 through 8 all. Yesterday, we already started to look at page 3, looking at cross sections. Okay. Now, also, I haven't posted this, but I'm going to do this as soon as we get done with class. And I'll show it to you real quick. We have, or I have, let me find it. Come on. All right. Okay, guys. Yesterday we talked about the cross section. I'm going to put this link on here. It's a good little thing to help you with the cross section. So remember we talked about cutting a slice off? All right, so let's say I rotate this square. Where do y'all want to cut? Tell me when. Okay, so when you cut right there, it shows you what will be created based on that cut. Okay, so remember we were trying, you have to come up with the type of cross section on your homework. This thing, you can redo it. You can rotate it a different way. Let's say we can cut right there. That lets you know that the cross section would be what shape? The rectangle. Okay, so remember on your homework, you're trying to come up with how the cross section is supposed to look. So this link could help you with that. And also I'm going to post another link that's a video of different types of cross section. So there's no excuse for you not to finish it. I just want to see if you can come up with some type of method, some type of answer. I'm not going to worry about how accurate you are. All right, and then, so we did those yesterday. I need you to go to this classics exercise, the next page on page 4. That's what we're going to do right now, and I'm going to check. So these are the steps that's going to help you with problem solving with tonight. There will be a partial key as well. We have homework check tomorrow. It's Thursday. Now, the key to this is this little part right here. You need to highlight or shade one of the bases. Because if you do not identify the correct base, your calculations are going to be wrong. All right, so I know it's going to ask you to name the figure. Okay. For number 1, this figure would be what? Yeah, rectangular prism.
Wait, was that a website where we could get on?
I said I'm going to put the link on Edmodo. Okay. All right, so we know it's a rectangular prism. Okay, so what dimension or what represents the base of the prism?
The rectangle.
Which rectangle? There's a bunch of rectangles.
4, 6.
Yeah,
6.
the 4 by 6, yes. Okay, the 4 by 6 represents the base. Okay, it has to be the 2 congruent parallel. Okay, now, our first one, the first thing you're going to calculate is the lateral area. The formula for the lateral area is the area of the perimeter times the height. I mean, not the area, the perimeter times the height, the area. So we know our base is the 4 by 6. So the perimeter would be 20, right? Because 4 and 6 is 10, double that, that's 20. So we're going to have 20. We're going to just substitute the values here. So the 20 is the perimeter. What's our height of our prism? 6. That's the distance between the bases. So that's the 6. So that means our lateral area is going to be 120 centimeters squared. Then we have to find the B. The capital B is the area of the base, where our base is the 6 by 6. So basically, I'm just going to do base times height, right? So if I just substitute that in, that's just going to be the 6 times 4. 6 by 4, okay? 6 times 4. So we get 24 centimeters squared. Yes? The distance around. Yeah. Okay, so to get this total surface area, we're going to take our lateral area plus the 2 bases, the 2 B's. So we already know the lateral area is the 120 times the 2 bases, which is 24. Yep, so our total is 168 centimeters squared. Okay? So today, right now, I'm giving you time to work on it. I want to see, can you highlight the correct base for 2 and 3? Name the figure. Can you fill in the parts? Because I'm going to come by and stamp. If you do an extra problem, like if you get to number 4, we had some students go on to they picked another problem besides 4. They might have did 5 or they did 6. If you do an extra one, that's going to be bonus points on your grade tomorrow. So you have to get your stamp for this page. And then if you do extra, that's bonus for tomorrow's homework. You got 10 minutes. Yes, individually. You can work together and talk about it, but you have it. I'm checking your answers on your page. Okay? All right?